So in this question, we need to find the value of x and y, circle geometry. So this is my diagram, not the best. Here's a better diagram. Pause the video and see if you can find the value of x and y. Because this question came in this year, 2025 January. I mean, it's a trend that it will always show up in the exams. So let's see if we can do this. Hold up. Before we do that, the first part of the question one asked us, why is x the same as angle NQL for 1 mark? Which means you just basically need to state that theorem, and you all should know that theorem. The theorem works like this. If there's a circle, a chord, which is a line drawn from any point on a circle to another point on the circle, that's a chord, that's a chord, that's a chord. The longest line will be a diameter. A diameter is actually a chord. This theorem says, if we have a chord and it touches the circumference, right? It's supposed to touch the circumference. And we extend, sometimes we use the word subtend, to the circumference from the end. This angle here, it doesn't matter where we do this. The angle will always be the same. It's a kind of crazy theorem. In class, we call it the Bonnier-Ayres theorem. The definition for it is that the angles from a common chord in the same segment are equal. That's one of the shortest ways to say it, and as you identify the angles, right? So for the exam, you'll write it like angles from a common chord, and you state the chord NL, and the angles are NPL and NQL. NPL is labeled X, would be equal because, you know, they came from the common chord and they are in the same segment. A segment is a part of a circle bounded by a chord and an arc. Major segment, minor segment. Okay, so you all figured out what x and y is? Need more time? Let's do it in a speed run, and I'll ask the editor to help me with the reasons. The reasons is normally the part of the question that annoy people with circle geometry, because you have to state the reason, then do the calculation. So how did we figure out x? Well, this is actually the last theorem, usually given as the last theorem in your notes, in your textbooks. If this is 63, this angle over here, he also has to be 63 degrees. The angle between a tangent and a chord is equal to the angle in the opposite segment or the alternate segment in the triangle. So you label all of this. The angle between the tangent MLR and the chord NL, 63, would be equal to NQL, the angle in the opposing segment. So that's a theorem. That's probably one of the harder theorems to see. That's why it's the last one. If this is 63, already established that x will be 63. Based off of the theorem, angles from a common chord in the same segment are equal, so 63 would be equal to x. So you write all those reasons, and then you put x is equal to 63. How do we figure out y? Well, these two dashes are not here for style. I actually did this question just now, and I forgot that. I forgot the dashes. This makes this an isosceles triangle. This isosceles will keep following me. So NLQ is an isosceles triangle. This side is equal to that side. And lots of isosceles triangles shows up in these circle geometry questions. If that is an isosceles triangle, 63 gets a next place to shine as well. This angle here will also be 63. Why? Why would that angle be 63? Base angles in an isosceles triangle are equal. These two sides will be equal, these two angles will be equal. So now you can figure out what y is going to be. So add 63 and 63. Get a nice 126. Take it away from the internal angles in a triangle. Get a nice looking 54. Y is going to be 54. They can also ask you what this angle is here. Maybe I can leave that one for you to figure out. What is that little angle up there? We can call it P and Q. Chat, figure out what P and Q is. You can. You just have to use one theorem. It's usually the first theorem. So leave that answer below. Let me know what topics you all want to see that are showing up in the trends, and I will give you some more. Love and blessings.